will let us know the online attendance so that otherwise it's just for our thing. You are all welcome to this meeting. This is the second meeting for the consultant conference. What is the deal is thing. And with that, we have an agenda. We will begin with a prayer. Then record attendance. The attendance sheet is going around, so please record your attendance. Then those attending online, we will request you to introduce yourselves. Then we shall have communication from the chair, reactions to the communication, if any, and then we'll proceed to the presentation of the draft feasibility planning report by the consultant. Thereafter, we shall have reactions and discussions. Then we agree on the way forward. Then closing remarks. So if there is any other business, let us know. Otherwise, we shall straight it out and end closing remarks. If none, then we proceed with the first item in prayer. I request Stephen Sally to give us the prayer.
Dear Father, thank you for everything. Thank you for freedom. Make this
Amen. So let us know those joining us online. Please introduce yourself. Yeah, Shafiq. Can you hear us?
Yes, sir. I'm live. I can hear everyone. Thank you, sir. Morning.
That is Shafiq Babayo, services engineer. Anybody else? David, can you hear us? Can you unmute your phone and introduce yourself? David? It's not just connected.
Maybe it's far away from his microphone.
David, confirm.
You may have to call him. Huh? I think he has unmuted.
You may get it. David? Are you with us?
Admit someone, yeah?
We want to confirm the attendance.
I think it's still connecting.
Nasifa, can you hear us?
It's still connecting as well.
Okay.
A mic. Is that what they're doing? Because I can see connecting too.
I think it's- I think it's fine. Is Nashika connected? David, are you with us?
It's still connecting.
What's the duration of that? Connection?
It should be. David.
David, are you with us? Can you unmute and introduce yourself so that you confirm that you are joined in?
I think he's done.
Nashika, is he connected?
Not yet.
Not yet.
But David should be able to
David,
hear.
David, we can see you, but we are not hearing you.
Yes,
Can you hear us?
yes, I can hear you.
Okay, good. So you're
Mm.
welcome. So we are waiting for
Sorry?
Nasifa is also
Yeah,
trying.
I can hear.
Okay, good.
Thank you.
Nasifa, can you unmute and then we confirm that you're with us? And introduce yourself.
Please unmute.
Sorry?
Nasifa,
Oh, nice.
Please unmute.
Nasifa, can you unmute and introduce yourself? You can hear
Good
us?
morning.
Yes,
Okay,
one.
good. Good morning. We'll hear from you. Hope you're fine.
Okay. This is Nasifa. I'm okay. How are you, sir?
Good. Okay, so I think we are ready to begin. We had already had an opening prayer from Stephen Sally. We are recording attendance, so we have registered. Hello?
Member, has it started? I'm not hearing anything.
This is Zungina Bosa. Can you hear us?
Yes, please.
You can hear us.
Yeah, I can hear you, but I was not hearing anything.
Okay, fine. So we have started the meeting. We have already had the opening prayer. We are recording attendance, and those online, we will have you also captured. So as a way of communication from the chair, I have just mentioned that the commissioner, public sector, I'd love to be present, but he's committed. So he has said we can proceed with the presentation and the meeting. And we are happy that the consultant has delivered this second aspect of this consultancy, which is going to present to us, and then we'll be able to see whether it meets the requirement and be able to proceed. Then recently we were required to make an update, submit an update on how far we're going with this assignment because the presentation place and the consultant submitted the status report, which is forwarded to the engineer in chief for that you can incorporate with other presidential pledges of the sector. So with those remarks, now invite if there are any reactions. We also welcome you, Engineer Nabota. This is the Assistant Commissioner in charge of structure and civil engineering. She is attending online. So members, if there are any reactions, let's have them before we proceed with the presentation. Harvin, you are joining in also? Are you available?
Yes,
Okay,
yes, I am.
thank you. So any reactions, members? If none, then I would like now to take the opportunity to welcome the consultant to take us to the presentation.
Yeah. Thank you so much, Mr. Chairman. I would like to take this opportunity to thank the CMT for giving us this opportunity to come and present the next phase of our assignment. I want to thank the members who are here and those who are joining in live via the online feed. Yeah, as an assignment, we had the 4 stages, and those included the production of the inception report, and then we had to go to the feasibility planning stage, and then after the feasibility planning stage, we shall be going to the field to carry out the field activity, and finally we shall do data analysis and then a preparation of the final report. And Mr. Chairman, I want to inform you that we've been moving smoothly. We were able to submit the inception report, and I think that was around the 26th of March. We were able to send the inception report, and when that was approved, we were able to dive into the feasibility planning stage. And Mr. Chairman, I would like to inform you that under the feasibility planning stage, we've undertaken a number of activities. Here, we've mainly looked at the literature review about the assignment. And mainly here, we've been looking at earthquake and having extensively done a lot of research about the subject, we were able to develop a sampling tool, both for the local governments that are most suitable to fall into this study, and the buildings that we feel will be most suitable to be studied. And thereafter, we were able also to look at the component of capacity building. And yeah, that's in brief. We're able to produce a report, and this report was submitted. And at this point in time, Mr. Chairman, I would like to invite my colleagues. We are a big team, Mr. Chairman, but due to the period we are in, all of us couldn't come, and we decided to come just the 3 of us. At this point in time, I think I will invite Manzi Solomon to begin the presentation. And after Manzi, I will also invite Cecilia Barbara Tom to also present her part. Thereafter, probably we shall invite reactions to the presentation. Thank you so much.
Thank you very much, Mr. Chairman. Thank you, Engineer Magembe, Team Leader Armstrong. Ladies and gentlemen, all protocol observed. It's a pleasure to have this opportunity to present what is coming at the tail end of several months of input from a coordinated effort between the consultant team and the Ministry of Work technical team headed by Engineer Lubega. And we hope that in the next few minutes or slightly over an hour, we will be able to share ideas really and reach a conclusive and satisfactory conclusion of this second stage of the current assignment, which, as you have been told, aims to establish the vulnerability of Ugandan buildings to earthquake or seismic events. So without any further delay, I will proceed to the first part of the presentation. So as we open up this presentation, I just want to provide food for thought. And that food for thought will take the form of a quotation. This quotation says, earthquakes do not kill people, but buildings do. So what do I want to take away from this? I want us to take away the fact that earthquakes in and of themselves can be quite harmless, apart from the slight inconvenience of moving at a faster pace than one is used to. They are actually not fatal in and of themselves. However, when they interact with the built environment, when they interact with structures that shelter and house human beings and their property, it is when they become problematic, which therefore leads us to conclude that this study could not have been commissioned at a more important time. We will therefore look at what the status of our buildings will be in regard to their earthquake vulnerability. Going on, I will just quickly show you what the structure of this presentation will be. I'll be handling the first part of the presentation, which in many ways is an appetizer. And then my colleague, Mr. Chong, will handle the second part of the presentation, which will be our main course. But as we all know, the main course cannot be as enjoyable without the appetizer. So the appetizer I will be providing is essentially a background to ask, very brief. Theoretically, what causes earthquakes? How do they occur? What impacts do they have on the built environment and on infrastructure? How do we detect and measure earthquakes? And then finally, what will be the theoretical framework for establishing the vulnerability of buildings in the event of earthquake? So that will be the structure of our presentation. It is two-pronged, and I will handle the first prong. Now, it is very important, of course, to start by establishing what the objectives of this assignment were as per the client's brief. And we have 6 major objectives that were given to us by the client, which is to say the Ministry of Work, representing the government of Uganda, following the President's directive to carry out the assignment. The first was to be able to carry out a theoretical overview. What is the literature that exists with regards to earthquakes nationally, regionally, and globally, and how can this existing research or scholarly undertaking enable us to provide context for this assignment? Secondly, can we select 2 pilot local governments within which to carry out assessment of building resistance to earthquakes? And upon approval of those 2 local governments at the end of this assignment, as you have seen, the first phase of the project, we can then scale up the project to cover the entire country. And we'll be showing you how we did that in this phase of the project. Secondly, once those 2 local governments have been selected, we move to the third stage, which is sampling buildings. Since we have a limited resource envelope, we could not sample all buildings in the 2 selected local governments, that we had to approach it systematically and identify a representative sample that will give us results that are credible and reliable, even if we do not have a population. We will, of course, show you what the methods work for sampling both the local government and the buildings. And hopefully that method statement can become a benchmark for the next scaling up the coverage in that country. We, of course, happily have so far engaged with the client, and he has assigned a selected team of able staff to us to work with, and we hope that as the project moves forward, we will be able to pass on the insights and the knowledge and the skills that we have had before, but which we have also acquired in the process of this interactive and symbiotic process to the client assigned counterpart staff. And then finally, but certainly not least, we will be required to establish an updated brief for this project. Exactly what were the takeaways, and can we advise the client to do something differently from the original project. That's being said, ladies and gentlemen. Let us now start to look at exactly what aspects are. And there is no better point to start than the art itself, because indeed, as the term itself says, it is self-explanatory. Earthquake, it is the composite what the shaking of the earth. And the earth, while it looks solid from our vantage point as human beings existing on its surface, it must be understood that the earth is analogously like an egg. It looks solid on the outside, but on the inside, it is fluid. And so it is the fluidity of the earth's component that creates instability on the solid surface. Now that surface layer is referred to as crust, and it is the motion of that crust that creates problematization and results in the earth. So we have the core, the mantle, and the crust. It is the fluid behavior of the mantle that causes the crust to move. And the reason that the crust moves is going to be shown in the next few slides. Now, the crust is not homogeneous. It is not a monolithic solid. While it is solid, that solidity is broken into fragments, which fragments are referred to as tectonic plates. Now, those tectonic plates move relative to each other. See? So this is a kind of zoomed in illustration of how two tectonic plates move relative to each other at their boundaries. One is moving to the left and one is moving to the right. And it is that friction generated during the movement of those plates that leads to a release of energy, and that release of energy is then experienced or manifested as a trembling or shaking of the ground. So moving on from that zoom in, I now want to zoom out and show you what the tectonic plates look like from a global scale. So you can see that this is the two-dimensional flattened representation of the Earth. And those zones that are in yellow show the tectonic plates of the Earth. On the extreme right, here, I hope you can see my pointer. On the extreme right, we have the African plate. See, while the African plate and the eastern segment of the African plate is not in a red zone, because red zone is the most problematic. It's called the Ring of Fire. You can see Japan down here. You can see California here. You can see parts of South America, Chile here, which are very earthquake prone. It doesn't mean that we who are not very close to the red zone are safe all the same, as history and scholarship has shown. This yellow also shows that we have a bit of trouble, which is justification for this project there. Moving on, you can see a zoom into the red zone, which shows you the most problematic and most earthquake-prone areas. However, on the right, you can see that the African plate, which is divided into two, that the Nubian and Somali plate, also can be a cause of major earthquake if occurring. And the problem here is the Rift Valley. I want you to just take note of that. The Rift Valley is the biggest cause of bathing cancer. However, what I would want to point out is that while these major places exist, there are also smaller places that comprise these major places. There are smaller places called minor or micro places, and the Lake Victoria Basin is close to one of these micro places. It's not as problematic as the Rift Valley, which is contained in a major place, but it can also be very. Moving on, this just shows you the semi-solid behavior of the mantle and how the crack moves as a result of this semi-solid behavior. So volcanic mountains can exist there. You can have trenches existing where the tectonic plates move apart. You can have one tectonic plate subsiding or subducting under the other. So this is the way the tectonic plates interact, leading to different geomorphological behavior. Moving on, once an earthquake has occurred, therefore, how do we measure it? Essentially, the seismograph, what is used to measure, and the seismograph can be digital or analog. Digital being a more advanced component version of the analog, but the functionality is essentially the same. Basically, you have an earthquake being incident on this structure that into the ground, and the pendulum moves relative to the movement of the structure. So that the pendulum then traces the shape or the behavior of the ground motion on this roller drum, which is transmitted or printed onto a paper under it. And that paper finally yields or returns this sort of message, showing you the motion of the ground over time. So this means the ground where you have huge spikes moving at higher intensities and higher frequencies as opposed to drop down there. Proceeding, we then have how we categorize the incidence of earthquakes. Now, there are two major subdivisions for earthquake categorization. First is magnitude, which measures the amount of energy released by the earthquake, and that is usually delineated on a scale known as the Richter scale. And you can see 5, 6, 7, 8, 9, 90 bigger than 5 in terms of energy released by that. But then also in terms of intensity, what's the impact that the earthquake has had? Like I pointed out, an earthquake in and of itself is not necessarily a problem, but when it interacts with human life, as we can see here in this green bubble, when an earthquake kills less than 10 people, that event is referred to as a disruption. 10 people, of course, are just as important as a million people. However, the scale of damage is quantified in terms of how much cost is needed for rebuilding and rehabilitation of the earthquake affected community, and how long really the economy and the society will suffer for that. Between 10 and 1,000, it is categorized as a disaster, and over 1,000 people becomes a catastrophe. Takes years to recover from, and it costs a lot of money. Proceeding, these are some incidents historically where earthquakes have struck and devastated society. Here is Chile in the top left corner. You see a huge crater-like crack. Yeah, it's a huge magnitude earthquake. This is our very own Uganda in Rakai, in the southern segment of the country. This is Haiti, which is an island in the Caribbean. And then finally, Japan. Now, Japan, as we have had in the global story, is majorly affected by earthquakes. But one of the other phenomena that occur in Japan is that those earthquakes are usually accompanied by tsunami. So huge ocean waves, especially where earthquakes have their epicenter in the ocean, and also invade coastal nations. Proceeding, this is the most recent earthquake event within the Great Lakes, so Uganda region. Those of you who are in Kampala or Masaka and surrounding districts, weeks ago must have felt that tremor. It was an earthquake that emerged from minor tectonic plate movement in the Victoria Basin. So while it didn't cause major damage, it still created tremors that were felt within Kampala around the region. So this is the most important event. Actually, a few weeks ago when the team of Power went to Kasese and Koima, we interacted with many officials at the district and lower local government levels. And they were telling us that in Kasese, they experienced tremors almost on a daily basis. Almost on a daily basis. So you can imagine how relevant and how current and problem this is. Now, moving on, once an earthquake has been measured and once the data has been collected, engineers and earthquake consultants like ourselves are then tasked with designing buildings that will not collapse or will not fail majorly under earthquake, that will give time for people to evacuate those buildings at the very least before the earthquake causes the building to collapse, which is the objective really of any structural design, ensure that people are. So how do we do that? Without going too much into the technicalities, I just want to point out that the ground vibrations that I experienced during an earthquake are essentially reduced to a single horizontal force, and that horizontal force is simulated as acting on the building, and then we study how the building responds to that horizontal force. And there are two methods that I use to do that. First is the static method, the second is a dynamic method. And in this assignment, we will be focusing on the dynamic method because it's more accurate and it represents the responsiveness of the building more precisely than the static method, which is more manual and therefore provides a more superficial assessment of the building response. Moving on, this flow diagram just shows you the breakdown of the two methods, that is the static on the left and dynamic on the right. The essential distinction here is linear and non-linear analysis. Linear being that assumes that the building behaves elastic, like a rubber band, while non-linear assumes that the building behaves like plastic material. Once it is formed, it does not return to its original shape. So that is the essential difference. And response spectrum and time history are the major methods we will be looking at. Though our focus will be response spectrum. If time history will require data that goes back 56 years, both in the past and the future. Right now, we will be doing this analysis on the basis of current data for present state events. Proceeding, this schematic just shows you how static analysis works, which is also a short interval representation of dynamic analysis. This motion is reduced to a single horizontal force. The building is assumed to bend in a one-dimensional axis, and then it behaves in that way, non-linearly, but then you assume that the entire building has been reduced to a single mass. So it is simplistic, it gives quicker results, but in a grander scale, it's less accurate. I just wanted to show how it works. So dynamic analysis essentially involves putting all these factors into different computational algorithms or equations, and finally zeroing down the dead share. So say grid zone factor, for instance, will be showing you how the data has various states response and how it structural type factor will be showing the different structural types shortage and how these factors, if they are building important factors, schooling, how many people are there building systems, what sort of material that is steel structure or is concrete, what wavelength does the aspect have, and how does the building vibrate, and what sort of weight contained in that building as a result of material. Proceeding, these are some of the equations we'll be using. I just wanted to give you an overview. I won't be going into the details here, but number of floors is a factor that influences the width of the building, land, shape, the weight, like pointed out earlier, and the height, the number of floors. You know, the third floor doesn't respond to an aspect the same way as the ground floor does. Bungalow and the skyscraper respond weight. See this? This just shows you what the response spectrum would look like. On the extreme right, you can see that the flows on this. There are many permutations, many possibilities of this. And so this response spectrum, being a dynamic analysis method, allows you to factor all these permutations of response into the analysis, as opposed to looking at this one-dimensional. So this is multi-dimensional, as opposed to being unidimensional, which is why we are opting for it in this assignment. Proceeding, response spectrum, and in this building response to aspect also depends on the type of soil. Buildings that are situated on softer soil sites respond differently from those firmer soil sites. The general rule of thumb here is that buildings on harder soils, on rock, are usually more resistant to earthquakes, and those on softer soils are less resistant to earthquakes. However, there are exceptions, rare exceptions, but they exist. As scientific analysts, that you also allow for the exception. Our analysis holds that these are some of the parameters, with the key being peak ground acceleration. That is what you're trying to find out. What is the rate of movement that the earthquake induces on the ground, and therefore induces building. Proceeding, this just quickly shows how time history works. So in this graph, a single building has been subjected to different types of earthquakes. The color code represents the different earthquake events, as you can see here. So the same building will respond different to different earthquakes. And so time history is then an attempt to aggregate all this data. Say, if in an earthquake of this magnitude, how will it be? So how can we find kind of middle ground between these variable responses to the building over time? But like I pointed out, requires long-term data, decades long data, 20 times. So we will not be applying in this particular time. Moving on, it is important also to note that we do not haphazardly do analysis, but usually when we are designing or establishing the vulnerability of the building to earthquake, we refer to existing standard codes that have been peer-reviewed and published by different national jurisdictions. And this map shows you the existence of documented codes across the world, with green representing those countries that may not only have documented codes, but also have compliance to those codes. So as you can see in Africa, Uganda is actually doing pretty well in Central and Sub-Saharan Africa. You can see only Algeria and Morocco and South Africa, which tend to compete with us. But most of our neighbors don't have any documentation, while we at least have some documentation, which we will be referring to in this assignment and hope to improve through the findings. So we need a pat on the back, but that is not big of that. Proceeding, how then, after doing the analysis and establishing forces, building, we design buildings for resistance to us. The first and most common approach, especially for skyscrapers and high-rise buildings, is to use what is known as shear walls, which are reinforced concrete walls that span the entire height of the building. And so the figure on the right shows you the different locations of the shear wall. This being a very good positioning of the shear wall, and this being poor position of the shear wall. Next method would be moment resisting frames, which essentially utilizes the connectivity and the rigidity of beam column intersection. And so how the forces are distributed or disseminated within the building frame is essentially a function of the robustness of those being for the intersection. Of course, the major weakness here is that you could have a weak story where, for instance, an architect has specified use of glass or use of steel in an otherwise post-concrete building. Then that unique or odd story becomes a weak link exchange. The third method would be break frames, where steel or beams and columns you produce diagonal members to stiffen the frame behavior of the building. And that produces rigidity. Fourth method would be one that we will actually be recommending, especially for low-rise buildings, bungalows. The other methods that are predominantly applicable to high-rise storage. This masonry, our ordinary bungalows are low cost and are made out of usual materials like brick. So how do we ensure that they are not subject to this sort of situation? What we do essentially is to tie the masonry. You introduce ties like bars, at alternate forces every second and fourth, or even third and fifth force, and then also at the joint of the masonry where the walls are weakest, you can create some kind of tying or connectivity. And also for long span walls, you can introduce columns and ensure that you do not have openings that are left without frame. So you introduce framing around doors and window openings, lintels, so that you allow really the masonry to be able to take on lateral load without failing suddenly. Proceeding, this is the final method that is used to break buildings against earthquake loads, and this is an advanced high-tech loads method that really involves separating the superstructure from the substructure. And in countries like Japan, they introduce either string or rubber bearing. So that, as you can see, the building has no bed isolation, but therefore, when an earthquake strikes it, the superstructure deforms. While in buildings that have isolated foundation, the superstructure remains standing and probably allows evacuation to be in time for life steps. Moving on, how then do we either pass or fail a building after earthquake events? Because sometimes buildings don't collapse entirely, but then you may need people to be reassured that buildings can be reused or it can be subjected to limited repair and retrofitting before being used. So on the left, we have the first method being broken down. This is the visual method. So for visual basic damage assessment, you really just have an expert going on to the site and filling out a checklist form, with red being a failure. The building is too damaged and you probably have to condemn and demolish altogether. With yellow being a building that may need to be subjected to some tentative overtime assessment, see how it behaves. In the meantime, it can still be used as a store, or it can house a limited number of occupants. While green says, yes, the building has passed the visual assessment test and period used normally. However, visual assessment has limitations. The least note being that you are limited by your senses, cannot tell what's going on inside. So how do you overcome those challenges? You do invasive but non-destructive tests, and that can be done through using energy forms that can penetrate the building members, either sound or optical energy. So it is sonar equipment. It's a bit expensive and we do not have it in Uganda, but in the event of an earthquake, perhaps if our resources can allow, we can be able to get equipment and be able to tell what the building's interior is like and whether it's safe or not. Moving on, what we need is a warning, an early warning. And as you can tell from this representative schematic, the building such as this, which can be key infrastructure, like oil installations down in the other side, which could be key strategic security infrastructure, which we do not need to fail in the event of an earthquake. It could be a key regional referral hospital, which we will not need to fail in the event of an earthquake. We establish some kind of beacon or sensory installations on that structure, and over time we see how it behaves tremors, especially since these buildings may be located in areas that experience regular tremors but not devastating. So we see how it behaves in this population. Like, deforming, is it remaining intact? Is it displaying significantly? We collect that data in a centralized data management, and then produce analytical illustrations, graphs, charts, which are then used by experts and other stakeholders to make decisions as to whether such infrastructure needs to be further protected or maintained in its current state. Moving on, I want to conclude this first section by just introducing what vulnerability analysis will involve, because all that I've been talking about, may appear to be all over the place, but especially this is the objective. After gathering data, after measuring and detecting the vibrations, after applying the codes and their stipulations to analysis, how do you conclude that the building is vulnerable? Basically, we will be collecting data in the field after this report has been approved, and having gathered that data based on different building types, the Bangalore, have share work, have momentary systems, we will then model those different building types within a software environment. And then we will simulate the earthquake loading that is stipulated by the Uganda Building Code and other international building codes that we use to benchmark. And then we'll look at the behavior of that building. Look at the behavior of that building, like the hospital, school, fuel depot, or a market, whatever. And then we'll look at its behavior over time, whether it fails or passes, and make recommendations whether that building should be maintained, whether it should be completed, or it should be evacuated and replaced altogether. Yes, that brings me to the end of this appetizer. I hope that we have been able to take notes, and I look forward to receiving the questions at a suitable time in the course of the presentation. Hopefully at the end. Thank you very much.
Yeah.
Okay, we have some people are doing that.
Yes.
Yeah. Zoom user, can you identify yourself or name? Asha, you're welcome to the presentation.
Thank you, engineer. Good morning, members.
Yes, so the consultant still has the floor, but once the person Zoom user to rename so that we identify who they are.
Yeah, ladies and gentlemen, Mr. Chairman, that marks the end of the first part of our presentation. And we want to thank you so much, Solomon Manzi, for taking us through basically the literature review. And I'm sure members now are abreast with the knowledge behind the literature about earthquakes. Definitely, when you review our literature review in the report, it's much wider than what we presented here, but we try to distill some of the main areas of the literature that we thought would share with you to appreciate the subject of earthquake and how it affects buildings mainly. At this point in time, I would like to invite Barbara to come and take us through the next phase of the session. And thereafter, probably we shall invite reactions.
So thank you, Mr. Chairman, for letting me present to you the next part of our presentation, the next part. And I'll get started. So I'll be taking us to the second part of the presentation, which entails determining all the processes that we use to achieve the different remaining objectives for this particular site. And the first objective that I will be handling is the selection of the local government, the two local governments that needed to particularly include in this study. So in order to select the two local governments, we needed to specify what a local government. And the definition of a local government for our study is that the local government will cover the area or region that a district right now covers. So that is what we have taken into consideration for our local government. But then to select these two local governments, we needed to identify the factors that influence the vulnerability of the building in this local government. And some of the factors that we are using or used in our study are techniques shown as we have here the first, occurrences and magnitude aspects, the population size and density, economic growth, human activity, and lastly, rate change. All these factors were weighted and then given a rank, and the ranking that we got was this, we got an assistance from our consultancy engagement with the different technical experts that we have in the field, and that's the ranking that we shall use and aggregate all these factors into a particular formula and subject them to the different local governments that we have in Uganda. So the first factor is the safety zoning. We all know that studies have been carried out to group different regions in Uganda according to their different vulnerability aspects. And in those studies, we developed three different zones. We developed zone 1, the first one here, and then zone 2, left line initiated, okay, zone 1, and then zone 3, which is the third. Each of these zones is a designated zone factor, with zone 1 being the most vulnerable zone and having the highest factor. So that means all the local governments in zone 1 are more vulnerable aspects compared to the remaining local governments. So those are the local governments that is submit access to the remaining factors that we have taken. So some of the local governments here include Tulisa, Toro, Pakwan, Oya. These are all societies, they're generally societies. And this is represented by superimposing the Uganda map that has different local governments and superimposing this particular map to the The second factor that we used was occurrences and average magnitude. Occurrences refers to the number of times a particular area has experienced an earthquake. And these earthquakes are quantified by their magnitude. They're called the size of the earthquake. So from previous data, we have had recordings of earthquakes with a different magnitude. And we find that Kasese, for example, here has about 19 earthquake recordings or occurrences. We can average of about 4.8 something. And then Hoima here has 14 occurrences with an average of 4.7, while Kardera down here has recorded only one earthquake that with a magnitude of 6. So once we look at this particular chart, we find that there's a correlation between occurrences and the magnitude, and places that have higher occurrences have generally a smaller magnitude compared to places that have only experienced one earthquake like Nigeria, which has, I think, the highest magnitude of this fall. So what we like to include places that generally have higher occurrences are more vulnerable to earthquakes compared to places that have lower occurrences and higher magnitude. So for example, we have this map that has been that details the different occurrences that we had in Uganda. The here are the locations of the centers during the period of residence. The blue here are those are the aspect sessions where we do recording of the different aspects that we have in Uganda. And then the black are the also locations of the centers for the geological survey. Our next factor is population. Then the places that have a high population are more vulnerable compared to places that are lesser population, because then you have more people likely to die from the event that an accident occurs. And also population density areas that are more dense populated are more vulnerable compared to places that are less densely populated. So if you look at our map on the right, we have these places in red. I think down here is and somewhere here is yellow. They have a higher population density compared to the smaller areas colored here, here and around there. The next factor that we used was economic growth. Economic growth generally means what activities are we having in that area? What are we using the land for? And it can be business, it can be construction of, let's say, any infrastructure that we have, like for example, the agricultural zone. So those are the different activities that we have. And when we have these activities, yes, we have those places attract so many people to come and do that, doing business. And that means those places will be more at risk because those places, because we will have more infrastructure being developed in order to house that particular population that has been in this area. So using this map from the National Planning Authority, have done a selection of places that are expected to have a high economic growth by 2040. And like you see here, we have those are going to be in the town, we have a particular population range, while those in blue will be slightly smaller towns compared to the ones in those are the places that we want to consider over time because they're more vulnerable compared to other places that have a lower economic growth. And the other factor that we use to manage this activity is other than the tectonic movement of states that we have. We also have managed activities amplifying the different safety events that we able to experience. And some of these activities include deep mining, dam construction, and hydrocarbon exploration. And like we know, under Zone 1, some of those local governments, we have the construction of the Hoima airport and also oil exploration in the Alberta region. So you want to consider those methods to be more vulnerable, as during this time they will disrupt the infrastructure due to the.
We have lost you.
Pardon? On this particular factor.
We are not hearing you now. Okay, now it is clear.
Okay.
All right, I'll just go through this particular factor once again. Like I say, human-induced activity. So you have man-made activities amplified safety events other than the movement of the tectonic plates. So some of these activities include dam construction, hydrocarbon exploration, and deep mining. And like we know, under Zone 1, some of those local governments have activities going on right now. For example, in the Alberta region, we have those we have the oil exploration, which definitely has different piping, which is started to the asphalt and causes different disruptions. So those areas will be more vulnerable compared to areas that don't have any human induced activity. And on my left here, on my right, we have active mining areas, and this just shows the different mining areas that we have. Like in Kasese, we have the cement mining here, and then we have also some limestone mining around Hoima, and then we have other areas as shown in the map that we have on your right. Our last factor would be to very soil conditions. Remember, building bricks the soil, and this soil should be able to withstand the load from the building. So previously, it's been carried out, and been able to classify. So this is like the hard soils and thick soils. And from here, you can tell that thick soils are more vulnerable to earthquake resistance compared to other soils. So some of the weak soils that we have for previous studies are clay, silt, and poor degraded soils. This is because these particular weak soils are susceptible to the liquefaction phenomena. Liquefaction phenomena is just the process by which water enters or water goes to the water, the molecule of the soil, and they liquefy the soil. You have the soil being less rigid or less having a lesser ability to take on the loading from the different buildings. So this right here is a map that we have. So, like I said at the start, we have all these factors being weighted and aggregated into a formula that were subjected to our 36 local governments under Zone 1. And Okare has the highest weighted because, like I said, it causes building, local governments to be more vulnerable compared to magnitude and the prevailing soils, while the population density, economic growth, and human-induced activities take a lesser weight compared to the above. So this is Okare, this is magnitude with a ranking of 1, and then these are the remaining factors. So this is an extract from the weighted table or sampling house that we used to develop our 2 local governments. And I'll just try to briefly go through that using Hoima and maybe even here that we have our local government standard Zone 1. So Hoima has registered 14 occurrences of earthquakes, while Limada has registered 0. So we tried to go the total occurrences of all the earthquakes and then go the proportion of each local government. Then the magnitude we did the same, we got the average, and then those above the average given away to 1, while those below the average are given away to 0. Same for population, those above the average is given away to 1, while those below were given away to value of 0, together with the population density. So under economic growth, we also studied using the other map that I showed you, that sectors that are going to register a high economic growth shall take on a value of 1, while sectors that are going to register a low economic growth shall take on a value of 0.5. So Hoima shall take on a 0.5, while Rwanda will take on 1 because of the high projected economic growth. And human-induced activities also noted that areas that have human-induced activities will take on a value of 1, and those without taking a value of 0. For soils, we took areas that have coastal soils because coastal soils are more vulnerable to earthquakes, take on a value of 2, and other soils a value of 1. But we couldn't use a 0 because soils are usually not earthquake proof, so at least you have to include that percentage. And if a building is a hard soil, it may still topple over the event that an earthquake has. So using our formula to get a total weighted for Hoima, which is a 5.3, Rwanda has 3.0, and took the first 2 local governments, the highest weight is the Hoima and Kapete, and then the Rwanda here ranked in the 17th. So Hoima and Kapete were our 2 local governments that shall be studied in the next particular phase. So those are our 2 local governments, local government, and Hoima local government. So the second factor or the second objective was the selection of buildings. This now determines local government, and we needed to come up with some factors that were to be considered for this building. But before we come up with the factors, we needed to categorize our buildings. What type of buildings we have? So basically, a building category is a building of similar institutions. So for example, here we have educational centers. Which educational centers are primary, secondary, vocational, university. All these are learning centers. So we needed to categorize all that. And then, for example, we have storage facilities. We have these are things that generally store food or whatever it is that you want to store. Some of those are warehouses and any other buildings storage. And then there have hospitals, we have public and private health centers, which private health centers will be covering clinics and drugstores and all the different health facilities that we have. So in the end, we came up with 11 categories. All these 11 categories form a building set. So in one particular building set, we have 7 categories. So with that in our mind, we needed to come up with factors that are going to enable us the next this particular building. So some of the factors include importance of building, size of the building, proximity and height difference, condition, and building occupancy. So the first factor that we shall be looking at is the importance of the building. So under importance, we know that the primary loss of the primary effect of an aspect, the loss of human life. So you need to include buildings that have that several more persons. But we also needed to consider the fact that there are certain buildings that need to remain vital or need to remain functional the event that an aspect occurs. And also buildings, for example, which is just a sectorial facility, because once an aspect occurs and hits this building, you realize that more people will die because they have the same occupy in a higher setting on different areas. So those buildings will be more important compared to buildings such as storage facilities that just houses that are very important. So on your right here, we have a table showing the different importance factors for the various buildings, and with the assistance of our technical experts, we came up with these different importance factors. So here we have hospitals being having an importance factor of 0.1. So these are the most important buildings that need to have. Secondly, we have the gas or petroleum facilities with an importance factor of 0.12, and then educational centers and students coming in. So in that order, we have the most important buildings that need important buildings. Our second factor will size of the building. Size of the building is defined by a building height and the building. Because with the height of the building influences how your building is going to vibrate in the resident aspect time. And we have solar buildings vibrating at a particular period compared to the shelter buildings, and the solar buildings will be more vulnerable to our studies compared to the shelter buildings. And under geometry, remember that different shapes of buildings and they are categorized into regular shapes, like we have two, which is the more rectangular, and irregular shapes as the LUGH shape. And these irregular shapes are more vulnerable because they have different masses along their story. So once you have different masses or less uniform masses, you're going to have to sway more differently compared to others, and those will be more vulnerable compared to the regular. Under proximity and height difference between buildings that are closer together are definitely more vulnerable compared to buildings that are far apart, and also buildings with a different height difference will be more vulnerable compared to those with a shorter height difference. Like we have here on your right, this picture shows that these buildings are so close, and because buildings vibrate at a different mode, like we talked about in the literature review, we find that those that are close together may end up hitting themselves or pounding each other compared to those that are far apart. So we need to include buildings that are more close together and have a shorter height difference between themselves. And then our other factor that we shall be considering is the condition of the building. How is the building generally? How is the setting of the building? Does it have cracks? What maintenance has been carried out on it? How old is the building? Because also age determines what exposure it has gone through, what basic exposure it has had before. So for structure defects, we must justify those as cracks. That our buildings have cracks. So buildings with more cracks are more vulnerable, as these cracks are particles of energy with an aspect of that. While those that are buildings that have that are well maintained are less vulnerable compared to buildings that are less it's well maintained. So maintenance probably have more retrofitting mechanisms, building, and maybe more machinery, something like that. So buildings that are less well maintained are more vulnerable to accidents. All the buildings are also more vulnerable to accidents because they are being exposed to seismic loads, and also generally buildings that are old may not have been designed for seismic setup that seismic. So we need those buildings. We need to use those more of those buildings compared to that have just been put up. Lastly, our last factor will be the building occupancy. Like I say, the primary effect of assets is the loss of life, and buildings that have more parts in them, you end up having more death and maybe a higher categorization of the assets compared to buildings that have lesser parts in them. And then for this study, we took up 4 different categories, and these 4 different categories we got it from the FEMA, which is the Federal Emergency Management Agency for America, and they categorized the different categories. The category 1 is the most occupied, category 2 is the highly occupied, category 3 is the low occupancy, and category 4 is the least occupied. So we got different rankings, which are we want to include the category 1, this is the most occupied. So it can also be used with data building occupancy factor to be able to start. So particularly for the selection of government, we shall be engaged with different parts of the field, stakeholders, for example, the CAWOS, which is the Civic Administration Officer, and then also different engineers, also using those 2 local governments to be able to help us select those buildings that we shall include in our sample size for this particular study. So this is a summary of how we have conducted this sampling tool. And the first that we did was consider the selection of come up with identified factors that we have considered for the local government, determine the 2 local governments, Kasese and Hoima. And then in those local governments, we went further and to come up with determine the counties that are in the local government. And in Kasese, we have 5 counties, while in Hoima, we have 4 counties. We also went to determine the population size in each of the local government, just to help us with the distribution of the building centers that we talked about. So with that, from here, for the building, we needed to start with identifying the average unit cost of testing. For the average unit cost of testing the building, we came up with quotations for different unit prices of the structural test and the testing process that shall be undertaking. After that, we sent those to different laboratories, and then we compared and got the most favorable unit price to each of the tests. Having gotten the most favorable unit price, we also went further and determined the average cost of getting the lowest story, the average unit cost for a unit, a single story, and also got the average unit cost for a multi-story. Multi-story, we have assumed 0.5, we have 5 different levels. So that determines our average of the unit cost of one particular building. Having gotten the average unit cost, we also determine the total budget for field testing. This is exclusive of accommodation and allowances, just only and only that's it. So with that, we're able to come up with that sample size, which was our third step. The sample size goes by getting the total budget out of the average unit cost of test a particular building. So with that sample size, we went further ahead to determine the building set. So this was given back. So our sample size is 161 buildings, and the building set, we have to get 131 divided by the total number of buildings in a particular building set, 27, and we got a different number of building sets that shall be identified for this study. So after that, distributed building shall be distributed set among the local government, and then for the counties, this is the proportionality and the population size, and then having distributed the building set among the counties, which are further go and distribute the building into the category. And then having quoted the number of buildings, subject those categories into four, we shall subject those categories. So no, subject the factors that we have previously mentioned in particular building that our building that is for our study. So here is a formula of what we shall be using to get the different number of buildings in a particular category. So NC here is the number of buildings to be sampled in a particular building category, but wanted to use both the important factor and proportionality to be able to get us a very representative sample in each of the counties. So NA here is the total number of buildings to be sampled in a given county. So for example, if one county take on a 2 building set, that means the total number of buildings here shall be 20. And NC here is the number of building categories available in our particular country. So like we said, our building set has 11 building categories. And this one is just to make sure that we have at least at least a category in our sample. So in the event that you don't have one particular category that counts, let's say for example, because you're counting and you don't have a bank there, so our NC reduces from 10 because now we have a bank for a particular category and it needs, so you end up having 8 at 10 instead of 11. So here is the process. I think this is our side. The third objective that I'll be tackling is the method statement for field testing, and it's just a process map for assessment of building structural integrity and earthquake resistance. The first thing that we shall do is all the approving, like we have here, with the different stakeholders that are going to be in the field. This is just to give them give them a brief of what our objective is for this particular study. Having held a brief with the different stakeholders, we shall carry out the second activity, which will be preliminary site visits to the identified building. And in that region, we want to understand the scope of the site, and what geotechnical tests will be doing, what structures the building require. And then having done that preliminary site visit, we shall also come up with a documentation. One, if the client has a structural or a good drawing, but if they don't have, we shall be able to come up with a good drawing for that particular building that we have identified. Because this good drawing will be able to let us know which test areas are we going to use in a particular building. And then we will also perform the measurement with the different aspects of the building owners, whoever would have given us those different documents. Having gotten that, we shall send our field and laboratory people to the field to carry out the tests that we are going to mention later on. And then they'll also be able to come up with the photos that will help us in our analysis back at office. Having carried out the analysis, we shall study the findings and then give interpretations of these findings, and then finally generate a report that has all these activities that we have been carried out for each of the 121 buildings. So some of the field tests we have was that field and lab tests that shall be carried out for the buildings like stated in this table. We have the as-built drawings and the size of the structural elements that are going to be developed for the model. The setting of reinforcement here and the size of things are going to help us check the adequacy of the existing structural elements that we have against the existing project. Down here, these parameters, unit weight, analysis, and moisture content, they help us to just look at the stability of the soil that we have in liquefaction. Like I said, liquefaction is how where we have the water going to the forward of the soil that we have below the field. So in case we have a weaker soil, we will have our say event that aspect of that. So the other remaining steps that we have here, this is generally the relevant of each of those to our research. So some of the equipment we shall be using are shown here. The Schmidt hammer is to get the computer strength of the different elements, and then performance AI and CPR is the can't do the reinforcement that a particular building, what rivers do we have, what size of lakes do we have, so that helps us understand that. Concrete core here just helps us to extract some of the cores that we need to go back to the laboratory for testing, and then accelerometer and vibration help us see how the different vibrations that a building experiences. This is about 2 minutes to subject a big acceleration, while we can generally put the entire the differences that we have in those systems. So the other objective would be the transfer of knowledge to the counterpart staff that have been selected to deal with that. So the first thing that we did was carry out a training with the them, which was done on Saturday March, just to go through what they know, what they expect, and also give them some of the things that we had already started, some of the areas that we already started going through, and hear from them how they want the presentation or discussion or transfer of knowledge to be done. So some of the areas that we have identified are literacy, development, consulting tools, fieldwork, data analysis, and report preparation. For literature review, we shall be conducting it through presentation and discussion for 18 hours, broken down into 2-hour sessions. And the tentative test for this will be starting on the 10th of August, that is we have received the approval of our feasibility planning report. And then development of the sampling tools are also be via presentation and discussion for 4 hours, we broke it down under 2-hour sessions. All of this will be done in a single hotel step. Fieldwork, which will first go through the presentation and discussion, just to go through the different labs that live at different fields and laboratories tests that we shall be carrying out, and generally how do we carry out, what are the first things that we do, and then further for our head for demonstration, the field or site that is from September 2021 to the 23rd of November 2021. So that analysis, having come back from the field, we shall just come back and demonstrate that how do we carry out analysis, what software to use, what parameters to be put, and finally come up with a report preparation through presentation and discussion. So all of these training areas, that's each and every training area, we intend to carry out an evaluation of how the training staff or counterpart staff are perceiving the entire process and how they have progressed. So with this, we'll be able to have feedback and also engage them in the areas that we need to improve, and maybe if they need more time, we also incorporate that in the training plan. So generally, all these are tentative dates, depending on the approval of the feasibility planning report. So here I would like to have Solomon take us through this particular process that we have been.
Thank you very much, Barbara. Mine will be a very brief simple task. I had the opportunity to get a team from the consultant's office that shortly before the lockdown period commenced, traveled to two selected local governments, that is Kasese and Koima. And while there, we kickstarted the process that is ongoing, and we continue till the field work, the submission report has been concluded. And one of the first things that we did while there was to meet with the district officials in each of the two local governments. So our first stop was Kasese, where we met the chief administrative officer, district engineer, as well as the officer in charge of building. And our purpose was to start a conversation, to introduce the project, submit our cover letter, other formal documentation for the client, and explain to them what the relevance of the project will be and what our expectation of their involvement at this stage is, which is essentially to give us a feel of on the ground conditions, because we do not want it to be a completely abstract or top-down process. We want to involve them, we want it to be consultative, and we want both the technical and political arms of the local government to feel that the ministry and its assigned agencies, the consultants, are approaching this from a participatory perspective. So that was our objective. On the 7th, we were interpreted for that purpose. On the 10th of June, 2021, we were in Hoima, that purpose. Next, the deputy car in Hoima, as well as town clerk, newly created this. And following from that, we, because of the lockdown, decided to use virtual methods of now carrying the conversation on the district to the lower local government level. And we got contact of all sub-county chiefs, all sub-county chiefs, all senior sub-county clerks, each of those local governments, and set up virtual correspondence spaces, that is, mobile chat rooms on WhatsApp, as well as mailing groups. And we have since been engaging with them to provide us with viewing lists in each of their local governments, which viewing lists we hope to compare with our own internally generated data, which we are sourcing from government documents and online sources. So that at the end of the day, we have an objective approach to the sampling process that my colleague Barbara has been taking. So at the moment, we are still receiving those viewing lists and continuing to engage with them, hoping that soon, if the lockdown is lifted, we will be able to then travel there and tie up the loose end of some of the engagement, or at least secure a special movement permit from our client, Ministry of Works, to enable us to move there while observing COVID-19 special operating procedures. Of course, ensure that stakeholder engagement is carried out expediently and over.
Stakeholder engagement that we have been carried out. I'll just briefly talk about the challenges that we have faced for this particular feasibility planning stage. And like we have listed below, we have to use the credible process of online. And because we definitely needed to look at data for our past objectives. But here we have tried as much as possible to have very standard processes for getting credible process by carrying out by first following a code of practice, which for example the basic code standard different basic codes that we have had out there. And then secondly, putting publication which was done was a corporate purpose, and that second credible source. After that, we took on a textbook as our side, and then finally some of the research things or papers that people that are interested in research have also carried out. The other bigger challenge is the COVID-19 pandemic, which like Michael Solomon has said, we have been trying to liaise with the different institutions and facilitate using online platforms and also following the SOPs. But also for the next phase, we intend to adopt the SOPs that the Ministry of Works and Trust published for the building and construction industry. So the other challenge has been a limited published precedent for the sampling tool, which has been feeding into the direction of the local government, and also the sampling tool for the building. Here we enlisted the services of a professional statistician and also have been using approach scientific analysis for best practices. The other challenge is limited access to government records and bureaucracy of government structure. So, in conclusion, the two most suitable local governments for our study were identified as Kasese and Hoima local government, and then the sampling tool or sampling size for our building was also developed, and the estimated size was 121 buildings, like I said. The training plan has also been developed and we await approval from the client, for the client counterpart staff, and then we are also able to submit a feasibility planning report, which we await approval from the client. So I'm glad, and I'm glad to conclude with the particular presentation. And I would like to welcome Engineer Kenneth Mangebe to give us a wrap of the entire presentation.
Yeah, ladies and gentlemen, that's what we've done so far. And I would like to thank my colleagues, Manzi Solomon and Barbara Cecilia, for the wonderful presentation. I'm sure all of us now have a basic understanding of what we've so far done in terms of the literature to do with the subject of earthquake and the effects of earthquake and how these affect building, and finally how we are going to carry out analysis to determine the vulnerability of buildings in the two local governments. And like I told you, definitely we've spent sleepless nights gathering information here and there, meeting different people. For some sources, we've had to partner with some colleagues of ours abroad to be able to get us some of the journals. Some of the journals were a bit expensive, but we found a way of acquiring them. And we are pretty comfortable enough to say that and confident that we have enough knowledge about this assignment. And that's how we're able to develop the sampling tool, where we had to come up with the two local governments and the suitable buildings. It hasn't been a very easy task, I should say, but we painstakingly had to look for all the relevant indicators that would help us to crystallize in a way of eliminating those that we feel are less suitable to have those that are more suitable. Our assignment, our scope of work was to cover two local governments. Like Manzi informed you, Uganda has over 100 local governments, but we had to use the elimination method and come up with a region that is more susceptible to earthquake, and then further use other indicators, what we call factors, to be able to crystallize and find out which of those local governments are able would fall within our study. And thereafter, definitely, we go to the two local governments as Success and Hoima, but you can't access all buildings there. So then we also had to develop factors, and using both qualitative and quantitative statistical methods, we had to rank these factors to ensure that we'll be able to come down to those particular buildings that will be most suitable for this study, because this study is going to be the springboard for the other studies that will be carried out throughout the entire country. So it was very, very important that this forms the solid bedrock for all the other studies that will come on board downstream. Basically, that is the brief of what we've done. It's been a very long process, I should say, that we embarked on. And like Solomon has informed you, a team was dispatched, and we decided, because it being a feasibility study, we didn't want to do a paper activity. So we decided to go and test it on the ground whether it is able to work. So that's why we, even before the end of the stage, we decided to go to the field and engage with the different stakeholders, beginning with the district officials and going down to the sub-county level. And we intend also to, it's only COVID that has hampered our activities, but we intend to also interact with the other groups. For example, we intend to interact with the business community, the association of the business communities there, to ensure that they give us the credible information on how best to sample this building. We will use the factors there to ensure from a technical perspective, that their help, with their help, we are able now to come down to the actual building, because they know all the buildings. We have the technical knowledge, so we'll be able to apply that to the building list that we'll have acquired and be able to zero down to the actual building that we want to thank you so much for listening to us. And I think at this point in time, I would like to invite reactions to our presentation, because we really want to know areas where we can pick it up and proceed forward. Thank you so much, Mr. Chairman.
So thank you, consultant, and your team for the elaborate presentation. I think it was quite well researched and quite you can see quite an effort that we had to get this done. Did you get anybody joining us? Asha, yes, we're already. I found somebody is picking up a hand. Asha? Okay, Asha, let's give you the floor.
Thank you, Engineer Kenneth, for your presentation. I must say you have done quite a good amount of work. I just have just a few areas of clarification that I would like you to throw more light onto. One of them being the estimated sample size of 121 buildings. I just want you to throw more light on how you have arrived at this figure and to inquire whether there are those buildings that you have put in place as a must assess. I would give an example of, for example, a hospital, for example, a school. My thinking would be that if we're looking at 121 buildings in these local governments, I'm hoping that mainly all the hospitals are covered among those you're going to assess. And also, I want to appreciate how this size has been arrived at. Are we looking at all types of buildings, all forms, all types of materials used? Because the behavior, the way they interact in an earthquake situation differs. If I'm using concrete, masonry, and maybe timber, and so on and so forth. Does this 121 sample include the different forms or types of buildings that we have? And do these local governments you put into consideration have these different types of buildings? I would expect that 121 sample would have something to do with at least a steel building, concrete, reinforced concrete, masonry, and so on and so forth. So please, I request for more clarification on how this figure was arrived at. I feel like it is so small. For the local governments we are talking about, let's have some more clarification on that area. That's my first request for clarification. And then the other issue was, I reviewed the feasibility plan that you submitted, and I noted that some earthquakes that actually, the most recent one was not even documented in what was captured. The most fatal earthquake that happened, I think in 2016 in Rakai and Mutukula border, wasn't captured in that report. There is a big, because I feel like Kasese and Hoima are within the same jurisdiction. Is it possible for us to get another local government? Because we have a fault line near the Tanzanian border that is a very high source of earthquakes. Why wouldn't we spread it out? Have one local government within, because Kasese and Hoima are within the same area. We could have picked also another local government, most especially near the Tanzanian border, where we have another fault line. You could put that into consideration. I don't know what my colleagues have to say about that, but I feel like if we pick Hoima or Kasese, being in the same jurisdiction, we may not get a representative figure as in comparison if we pick also another local government away from that. Thank you.
Okay, thank you, Asha, for your comment. Do you have anybody else? No, I think let's first see whether there's anybody else raising comment online before we. Anybody online with comment? None? Yes, Engineer Bosa?
Chairman, thank you very much. I would like to thank the presenters for the well-researched and elaborated presentation. Chairman, I have just around 2 issues. The first issue was on the selection of Kasesa and Hoima. Good enough, Asha has elaborated on it. When I looked at Kasesa and Hoima, I was trying to see the first presentations. That is why I was asking, if possible, they send us the presentation. I saw as if the most affected is around Lake Victoria, according to what they have presented. So now I'm wondering how again we are choosing Kasesa and Hoima. Anyway, I need to be guided. Then the other issues were those which, like the one in Mutukula, that earthquake which affected many people. Then they said somewhere that only buildings kill. Earthquake does not kill. Yes, I agree. Are we really looking at only the effect of earthquake? Anyway, I need to be guided, but this is assessment to buildings. But at times when earthquakes occur, they can even cause a fault whereby someone can easily even fall there. And it is not necessarily the building, but again, the building comes as an after effect of possibly that fault. We really need to look at all those details. Then the other issue, there is a national risk atlas and Office of the Prime Minister. I don't know whether you were able to look at it to really identify clearly in this, in Uganda, what they have already identified as the most risk area in regard to earthquake. We really need to see some of the differences you used in this report. And then when I saw there is a formula, the problem, I didn't get the presentation, but there is a formula which shows NC. NC equals that one. Yes, that formula, when I look at it, you started by indicating that the building, the way the height is, if they are too high, they can topple on another, then they can also collide within themselves if the spacing is close. But again, when I look at the formula, I'm not seeing those parameters being brought in the selection of the unit to be tested under each building. I don't know, I need to be guided because this is a new subject and a new area which we are handling. With those, I thank you. The report it has been really detailed enough. Thank you.
Shafiq, do you have any comment? Shafiq online? David, do you have, Shafiq, do you have any comment? Want to see if you have any comment, or if not, we move to another person?
Not really. Thank you very much, Chair.
Ashifa, do you have any comment? Ashifa, doctor. Pavin, do you have any comment? Okay, I take it that it doesn't have. David, you said you have a comment?
No, I don't.
Okay, so let's hear from Stephen, then I will come. Let's first get all the calls, because I'm calling to overload.
Okay.
Then we can react as well.
whether system to work with
As if we are not hearing. I don't know whether other people are hearing.
yes, contact student of Solomon, but it's not captured in the report. Maybe that's included. And also my other comment comes to the figure of the incident. Earlier, you have talked of the categorization of this. Where you have section, I don't know whether in this figure of the incident, you looked at the categorization, you just looked at the incidents without necessarily looking at the categories of that. Yeah, others we had been mentioned by Russia.
Chairman,
Yes, Engineer.
I have a problem. I don't know. I'm hearing someone talking, but the words are not coming out clearly.
Okay, he raised basically two issues. He wanted the consultant to include something on the systems that they mentioned. Something was not captured. And then he wanted more clarification on how the incidents were presented, because there are some categories that they mentioned earlier. So he wanted to see how they relate to the presentation. I hope that,
if possible, yes, that clarifies. But if possible, they can look at they can remove the masks. Otherwise, there is a way to is blocking the communication. I don't know.
no, but he has completed his submission.
All right, all right.
Okay, so I will also present some of the comments I had. There are some which are editorial, those I will just pass them on because they may not affect the presentation. But maybe one simple one in the editorial, the definition for local government, you may need to consult the Local Government Act or get the perspective of the Ministry of Local Government itself to know how they define local government, so that our definition does not clash with what is already known as the definition for the local government, the counties, sub-counties, and so on. Then in the objective of this particular phase of feasibility planning, there was an item that you have covered, but you have not mentioned. The sourcing of tools and equipment required for the assessment. It was one of the items we were expected. I think you need to plug in that, I think. So you need to include this in your objective, and also along the way, in the conclusion, and to indicate that how you have handled this. Because the information is there, but specifically not mentioned. Then move on. This was our first one, editorial. There's an aspect that was mentioned, actually in Acha's comment, about the occurrence of 2016. I actually saw it somewhere in your report. It's mentioned in the report. But perhaps, maybe, I don't know whether she wanted it amplified or something like that, because it was a reference aspect which triggered this presidential directive. So perhaps you may find need to discuss it more. It appears on page 14. It's mentioned there as I think you bullet it, but I would prefer you, if you made it Roman, then you have it as Roman number 3. 16 September 2016, Tanzania, 5.9 magnitude earthquake. I think that's the one. So because it is the kind of trigger for this directive, I believe that's why Acha is raising it as something that we need to expound on and see how you capture it better. But otherwise, it is mentioned. But what is not mentioned in what I had picked in the text in the document submitted, but it is there in your presentation, the recent one of June. I had actually noted it somewhere. The one that occurred, I think you mentioned in the Provuma area. Personally, I didn't feel it, by the way, but everybody was telling me that so it is not. I didn't see it mentioned in the report, and because there are some of these minor tremors that occur once in a while and so on. So given that it is more or less the most recent, and you have highlighted in your report, let's also feature it in the presentation. Then there are some areas where the text is not clear. Those are just tutorials. There's some other fundamental. In the issue of size of the building, I don't know whether this could be from the way the categorization has been done. But I tend to believe that geometry is more or less a separate factor. Because you have size, the influence of the height, yes. The geometry influences, but if you define it as size, it kind of becomes superfluous. I would propose that, in my view, that it's an independent factor to consider. So that you discuss size in terms of the height, and whether it spreads out regardless of its geometry. Then you discuss the geometry as an independent factor because it has quite an influence. So I would propose it given more prominence, not as a sub part of another. Then the other is in that matrix that you mentioned. I think it was wrongly referenced in the report. You referred to a different annex. So at first I couldn't find it until I eventually found it in a different appendix. But you need to, I think somebody has mentioned, I think you will need to elaborate further how this has been resolved. Then also on page 115, there's this reference to quotation, how you arrived at the unit price for the testing and so on. You refer to certain information which is not seen in the report. And you also indicate that you acquired quotations from engineering materials laboratory. It's not clear. Yet, I think when Betty was presenting, you actually stated that you had quotations from different laboratories, which you have not listed. So you need, if you maybe clarify on that and provide the missing information in the report. You can say we conducted this lab, and we finally ended up with this one because of FTP. So that is not properly captured in the report. Then I think in the conclusion, no, before we go to the conclusion, the updated project brief, it is not expounded. Perhaps we may need to capture some of the issues that we presented in the section report and also incorporate them. Like you mentioned in the section report, the scope management plan, the project activity list, the communication management plan, the risk management plan, and I think the comprehensive plan. So given that now you have done the research review, you have done the preliminary stakeholder engagement, you have visualized how you are going to move on to the field. So I think there's need now to draw a little bit of now how you think the scope, the project activity, the communication, the risks, and so on are going to be handled as part of the updated project brief. So then that one will now make it more solid. So then with the conclusion side, I think there are some aspects that you have not concluded on. You have discussed them in great detail, but on the conclusion, you have kind of left them out. I think you will need to to also incorporate them and then come up with maybe a specific recommendation that comes out of all these conclusions. Then lastly, in the statistics that feed into that the sampling tool, there are some figures that were not properly captured. I think you could have mixed the sources. We have highlighted them here. I think even addressed them, so I looked at them in detail. But when you go to that table, you will see the figures for Bunyangavu, the figure for the population figures for Kabarole, for Agadi, for Kakumiro, for Kamwenge, for Kivale, for Kiruhura, for Mbarara, and the Muvende are not correct when you compare with the others, because they relate to I think the figures of 2014 when you got the UBO statistics, and yet these ones I think they captured different figures. So you may need to reconcile that, and therefore this average figure may need to be revisited, and then you see how to update this. So I think those are the comments that we have. I can now give you opportunity to respond. Thank you. So you have another one?
Thank you. I also saw in the population figure, we use the first line figure as well as how the projected one. What was the justification for that?
Okay, I think the floor is back to you.
All right. I want to thank you so much, Mr. Chairman and members, for these wonderful comments. This indicates that actually you've been listening in and following very well. And to us, that's a plus, because we know that we are building on our studies. They are quite extensive, and we will try our level best to ensure that we attend to each of them. But where we seem not to have captured it very well, maybe members can feel free to expound on the comments so that we can comfortably respond to each of them adequately. I'll take the lead in the response to this comment. When it comes to, these are the comments that are raised by Asha. He talked about how we arrived at the sample size of 121 buildings. Ladies and gentlemen, as you may have heard, when Barbara was presenting, there is no way you can begin a study and you do not define the boundaries of the study. And part of the boundaries that you're going to set, you must have a sample size. We have a population in the field of millions of private buildings, or thousands or hundreds of thousands of buildings. And from that, we must determine a sample size. Now, a sample size really, there is no definitive sample size. Ideally, definitely, the bigger the sample size, or the closer it is to the population, the more accurate the results will be. However, here we were limited by definitely time, the time we have to undertake the study, and definitely the available resources. These were the two varying factors that we have to play with. Now, we definitely have a budget for the study, and out of that budget, there is a component that is assigned to carrying out tests in the field. That component does not involve other expenditure items like travel to the field, accommodation, allowances, facilitation to all the stakeholders in the field. We needed to get a budget that we know very well. This will be dedicated testing of buildings. So out of that budget, we had to determine the number of buildings that will be tested. So those would form the sample size. So we now decided to go out and get a quotation. That quotation was giving us the unit price of carrying out each test that you can ever carry out in the field. Now we had a list of tests. Barbara went through most of them, and so we had to determine the unit cost of carrying out each of those tests. So, but to ensure that we were dealing with a market rate, we decided to go out there and solicit for a number of quotations from various geotechnical and structural laboratories to be able to compare the different rates and come up with a fair market rate that we use. And having gotten all these quotations, we were able to come down to a rate for the test. And then we had now to determine the unit price of testing an entire building. Now, for us to determine that unit price, we had now to look at the unit price of testing the smallest building in a field. That would be a single storage building, and possibly the biggest building in the field. So when we went to site, when we went to the local government, we learned that the tallest buildings were about 5 levels, 4 levels, most of them. You could hardly find a building that is above 5 levels. So we had to determine the unit price or the unit cost of carrying out tests for the smallest building and the biggest building, and we got the average. Having determined that average unit price of testing a building with our total budget, we were able now to determine the total number of buildings that we can test within that site. And that number came to 121, because the truth is that we do not have a limitless budget, and also we don't have that much time. But then also, testing 121 buildings is a mammoth task. That is to say, as a matter of fact, we are working out a schedule on how best the materials lab will be able to mobilize and concurrently test a number of buildings in different areas. So we are trying to work out that. It has only been hampered by this COVID situation. We are still trying to work out how we are going to travel and which team will go with which team. But it is not also easy given the time frame that we are given. So in simple terms, that's how we arrived at 121 building, and basically that's how we are going to ensure that we conduct tests on all the 121 buildings. We will be able to probably present that schedule when we finalize our discussion. He alluded to the need to be able to include the most important building. And here she mentioned the hospitals and schools. If you remember very well in our presentation there, one of the factors that we're considering in the selection of building is the importance of building. We know very well that not all buildings are important, because at the end of the day, you would want to look at buildings that should be able to survive an earthquake event, and those that should remain functional after the earthquake has occurred. Here, when we are carrying out this analysis, we are looking at both destruction of buildings, but more importantly, loss of lives. Now, there is when we are conducting a judicial review, we understood that actually there are primary losses and secondary losses. Under primary losses, you're looking at the immediate loss of life when a catastrophe has befallen, because the biggest category of an earthquake is called a catastrophe. So in the event that you have a catastrophe, there are lives that are lost there and then. But also, consequentially, as a result of destruction of certain infrastructure and as a result of disruption of services, the earthquake can disrupt the way of life that outside ultimately there will be no knock-on effect or snowball effect where there will be secondary losses of life. For example, if services like electricity go out, even if you have a hospital but you don't have services like utilities like electricity, you don't have water, there will be loss of life. Then just imagine if you look at the tsunami, even when all your buildings are okay, you can still lose life, or you can have diseases that may arise out of an aspect event as a secondary effect. But here in our scope of work, we're limited to actually determining the vulnerability or the capacity of buildings to resist. So as we're looking at the importance of building, we had to take all of that into consideration. And that is where you see that at one point we had to create a ranking for us to be able to rank the importance of building. So we decided to have a number of experts that we went to, we presented to them this list and informed them to be able to rank. And out of the weighting that they gave us, we got this average weighting, which now we use, and we believe that we are comfortable to a certain degree of confidence that it would be able to rank the building according to their content. And even when you look at the ranking, if you can protest. Okay, fine. Anyway, because Asha is online. When you look at the ranking, hospitals there rank highest. And now, why gas and petroleum facilities rank next? It's because definitely in the event of an earthquake and there is a fire, so many buildings, even those that may remain standing, may end up being affected. So we've really taken time, and also when we used the statisticians, they were able to help us in generating models that would help us be able to rank these. Educational facilities actually are number 3, because it is believed that if definitely an aspect occurs, kids normally are supposed to run out of the building. So yet a hospital should remain again functional after an aspect event. They check the event that there are any casualties. So that was taken into consideration. Now, she also talked about the building forms and types that we consider. Here, she was saying that hopefully we looked at the different building materials that can be used to construct buildings, and all the different buildings should be considered. Yes, this was considered, and as you may have realized, here we projected a few building types. We projected definitely we have a frame structure. Now, by frame structure here, in as much as we represented, we showed the frame structure and the base structure. But when it comes to analysis, it depends. If it is a steel structure, the analysis of the steel structure will be definitely quite different from that of the reinforced concrete structure, a timber structure. So there is just the dynamics of analysis, but all these have been considered as different building types. She was also saying that some earthquakes were not documented. We are aware that there are earthquakes that may not have been documented, ladies and gentlemen. But what we need to know is that earthquakes are not a static event. They always occur. When we went to Kasese, they told us that we are used to that. There are tremors always, and even the ones that we talked about, the ones that occurred in Bukuma, you cannot document all of them. However, the other thing is that in our scope, since it's a study, we needed to be credible in how we are approaching this study by not just documenting every aspect that occurs, but by using data that has been gathered over a period of time. And we believe that even the aspects that are occurring would still lie within the same projection or trajectory of the previous occurrences that have happened in this. So our study is based on previous occurrences but it will be helpful and useful for future occurrences. We believe because earthquakes definitely take time to happen. And we want to believe that this study will still be relevant over a period of time. So we may not have to document every occurrence because anyway, we have a time limit to the study. Kasese and Hoima were in the same jurisdiction, yes. Now, there is a concern here that has been raised by a number of members regarding the selection of the two districts, Kasese and Hoima. What I can say, ladies and gentlemen, is that if it is a study, it was very important that we use a statistical approach in selecting this. In statistics, definitely, they are both qualitative and quantitative approaches. We definitely had to use basically the qualitative approach, and the qualitative approach to that extent, we were able to now say, okay, fine, which districts are most vulnerable to earthquake? And those are the districts that were indicated to you in zone 1. However, now we had to come down to a quantitative approach and also qualitative judgment in a way by looking at different factors that will lead to vulnerability of buildings in a particular local government. So here we were looking, because let me do an analogy. There is no way I can, if I'm told to research about nodding syndrome in Koboko, I cannot say, but Koboko and Arua, I cannot say, but why didn't you consider Kampala, which is far away from Koboko, when actually the hotspot is in Koboko? So here we're looking at those two districts that we believe, if we studied them very well, and the effects of earthquakes on buildings in those two local governments, we will be able now to get a basis, because this is like a baseline study that will now help us to be able to carry out further studies in other local governments. This is just the beginning of this, but we believe that it will be transposed to all other local governments. So we wanted to ensure that we use the statistical models and approach to arrive at this, rather than using judgmental that, this district is so close to the other. Because the ones that we've actually used a number of factors. We used the seismic zoning. We looked at economic growth. We looked at the population density and population in this local government. So all these human-induced seismicity. So all these factors were used, and we came up with the model to ensure that we come up with those local governments that are most vulnerable. So we really, thereafter, possibly we can now say, can we begin with this particular district? We believe that this is the next area that we should look into. I think that's it under Asha. So Engineer Betty Nabosa talked about most affected was the Lake Victoria. Lake Victoria, I think she was also alluding to the most recent occurrence, and that I think we've responded to.
No, after that issue, the one of Asha, that why that
yeah. Okay, yeah, it's the same issue. The criteria that we use to arrive at the other two local governments, and I think we've explained that. The next was buildings. Okay, she was talking about the icebreaker that we had, where we are alluding to buildings killing people and not earthquake. I think, yeah, well, as an icebreaker, we are trying to show the relevance of the study. That we will stay with earthquake for as long as we live. But we need to manage its effects, as simple as that. That, Mother Nature behaves the way it's meant to behave. But how do you play around and survive with Mother Nature? That's why we're saying, no earthquakes, they will always occur. They've occurred before humanity. But how do we make sure that we survive the funds of their occurrence. And that's what we're trying to mean, and it was rendering importance to this study. And so she was talking about the scope of work, that is not only building, so many other things, and they are fault lines. And yeah, we've seen a great fault that as wide as the football pitch. We've read about those, but unfortunately, our scope was limited to building because earthquakes affect so many things. They affect almost every sector would be affected. But when it comes to the infrastructure area, we singled out just building, and but this is not to underscore that that other areas. This is not to mean that other areas are not equally affected. Yeah. Talked about referencing with the National Risk Atlas under the Office of the Prime Minister. Well, we shall look at our reference material because I should be honest with you, when it came to literature review, we all had to go out there like hunters and look out for material and read and essential information. Then we had to bring it, presentations after presentation, analysis of that information, sieving it, seeing what is relevant, what is irrelevant, what is credible, what is not credible. But in terms of the references, some of it we got it from abroad. We have colleagues of ours, but some of this, because the colleague of ours who got most of the information from the university and from other scholars around here, I don't know whether he visited the Prime Minister's office here, but we will take it upon ourselves and find out whether we reference this particular atlas. And if we didn't, we will most certainly pick information out of it and see how we can bolster our efforts here. Formula to determine buildings in oh yes, NC. NC is a model that we are meant to use to determine the number of buildings in each building. Maybe just that's the formula, but let's go to the building category. Now, you can see there the building category. We have to ensure that we look at our population has to include all the possible buildings that can ever be in an area. And after looking at all the different buildings, we had now to categorize them, because some of them are similar in a way. We had to categorize them. So we came up with 11 categories from A to K. Those are 11 categories. And in each of these categories, there are different types of buildings. For example, when you look at a residential building, they are bungalow homes, they are apartment blocks. And we are saying that if we are going to test buildings in a particular cluster, because we had to break down each local government into clusters, and this followed the counties there. So we say that we must ensure that when we are testing in each of these categories, we must get a representative number, a proportion of each of these. So, for example, if in a category of residential buildings, they are bungalows, they are apartment blocks, how do you arrive at the number of buildings that we are going to test in that particular category? That is NC. N is the number of buildings in that category. So we needed to know the number of buildings within that category. What you need to know is that in as much as we are going to look at all buildings, but also we must be proportional. If some buildings are more than the other, then there must be proportionality that those that are more are looked at more than those that are less. But then also we say that, okay, fine, some of them could be less, though they are less, but very important. So that is why we are looking at this particular model has two factors, the importance factor and the proportionality factor. So those were the two varying factors that we looked for here. That at the end of the day, we need to make sure that we look at both proportionality and importance. This, by the time we arrive at this model, this is the result of an exercise that involves a number of discussions, a number of models, a number of iterations to ensure that this model actually will give us exactly that. Because you're looking at importance, if they are schools and they are say 5 schools. However, we have 1,000 homes. We are saying that with the importance, we should relatively look at more schools. However, proportionally, there are many more homes. So we had to juggle that and ensure that we come up with the number of buildings in each of the categories. Mr. Stephen Sally here talked about systems for building building structure systems. And I think I stand to be corrected, but I think he wanted to know whether we looked at all building systems, including masonry walls.
No, not there. So like that time, some of the masonry systems are not in the report.
Yeah. Yeah. Now the masonry systems are not. They are not expounded in the literature review, simply because when it comes to analysis of buildings, unfortunately the models that we use are not ours. They are imported, and these guys emphasize more these framed and big buildings. However, there is a lot of literature about masonry units. And for example, when we read when we refer to the code in Kenya here and some textbook, they give just provision. If you have a masonry structure, what are some of the provisions that have to be in that building to ensure that it will be earthquake resistant? Certainly, we can never have an earthquake-proof building. It has never happened. But we try as much as possible to ensure that to a certain degree, people will be able to evacuate and it still remains operational. And most of the masonry units are normally small buildings, and if the high-rise buildings are limited to 4 levels, so they decided to just make provisions that if you have a masonry structure, these are some of the structural provisions that must be in. And when we go to the field, there are some of the issues that we'll be looking out for and creating an assessment to form a picture of which buildings generally are structurally vulnerable and what the remedial measures could be. Categorization of earthquakes and how they are used in the study. Now, yeah, he is referring to the other scale that he showed, where earthquake is categorized in 3 ways. We can go back to that particular slide. Ladies and gentlemen, in as much as that one there. We don't have it. Okay, now here we categorize earthquakes into 3 broad categories. Those that cause disruption based on the number of casualties and the cost to infrastructure. Then those that come to be disastrous and then catastrophic. What we can say is that for this categorization cannot be directly be included in the study because these are empirical studies that happen over a period of time to be able to categorize the different aspects. However, when they are developing the code, which code now we use to analyze the building, all these are taken care of. Because you realize that, like in Uganda, they are saying that, okay, buildings in the western side are more susceptible to earthquake than buildings slightly next to them, and then those that are in the center. Now, at the end of the day, when that study has been done, they come up with parameters. The parameters that we projected here that we use in analysis. Now, those parameters are developed from those studies as a result of knowing the severity of the earthquake in the different areas. And so this parameter will vary depending on the severity of the earthquake. So we do not directly use this data as raw data that, okay, fine, now this earthquake is catastrophic, or it is 7 on the Richter scale, and therefore let us analyze the building. Because there's what we talked about, occurrence and magnitude. Those are two varying factors. The number of earthquakes that have happened and the size of the earthquake. You see, so all those factors, they are models that have been studied to ensure that they incorporated, and they come up with these parameters that are representative or simulate the likely event of earthquake in the future. Like I told you, earthquake is a long-term process, and a study can apply for a period of time. So we do not use them directly, but the parameters there simulate actually these different categories. Population figures. Oh, the basis of using a population figure from the table that we got from NPA. If there's the most recent data, would be more than welcome, because what we did was to definitely visit them, and we got this information from a colleague of ours, and we thought that this was the most recent, but I've not heard of a census that was carried out in 2020. It could have been a projection, but the last census was carried out, I think, in 2014, and that's what we used. And we believe that at the end of the day, it will also be able to give the basis for us to determine which areas would be most vulnerable, depending on the population and density.
Challenge was some districts didn't exist at the time, so we had to do cross comparison.
Oh yeah. That's true. Okay. Engineer Lubega raised a couple of the comments, and some of them were editorial in nature, like the definition of local government. We had an entire afternoon from 2 p.m. to almost 8 p.m. trying to define local government. And but most of the definitions that we got alluded to the fact that a local government is defined by the boundaries of a district. That was the general consensus. And so we use the district as the local government. But when you read further, there are sub-local government units, and
Are other members hearing? Asha, are you hearing anything?
yes.
I can't hear anything. I can hear you, but I can't hear the presenters.
You can hear the presenter?
Can you hear us now?
We were not hearing you, so we have missed almost some 2-3 minutes back.
We can hear you now.
You can hear us now clearly?
Yes.
Okay,
Yes,
we can go back to the comment that was raised by Engineer Lubega about the definition of local government. And we were saying that we took extensive time to be able to actually define what our local government would be. Because our brief was talking about local government, but they never defined. And the logical definition that we got was that a local government is defined by boundaries of a district. And so, because we know that from a district, if we go to a country, we decided to use the district as our local government, and then the study is going to be cascaded down to clusters that we are creating in a district. Because from a district, we went to a county and then sub-county. So in each district, we looked at the number of counties there, and then looked at the sub-counties within each county. So we cluster all the sub-counties in each county, and we ensure that we look at all buildings within those sub-counties in that county. Within the objectives of the study, we did not bring out the sourcing of tools and items. This, like we had indicated in our inception, at the inception stage, that instead of we procuring tools, we already have material laboratories that are existent and have these tools, and they are at our disposal to use them. And they have better expertise in using these tools. So we decided to work with the material laboratories who will carry out the test in the field. But we try to indicate some of the tools that shall be used.
So the issue is that the sourcing doesn't necessarily mean that you're going to buy, but that you have made arrangements with a certain laboratory. The information is there.
Oh yes.
But that aspect was just not captured among the objective and in the findings of all.
Okay.
So you indicate how you have handled that.
Okay. Yeah, he also alluded to the earthquake event that occurred in 2016 that triggered the presidential directive to undertake this exercise as a major event that we needed to expound on in our report. And I remember this was handled at the inception level. In our background, we extensively talked about this particular event and the effects of the event and where it took place and the magnitude and the effects and the areas that were affected by the occurrence of this. And but like he wisely advised us, we will include the inception report, parts of the inception report, in our updated project brief here, so that at least people can get to know what the background to this study was all about. Then also a recent occurrence of June doesn't appear in the report. Maybe we can include it, but like we say, really, earthquake is not a static event.
Because it was in your presentation.
Yeah.
And as well.
We can capture it there. All right. Here he talked about he talked about the categorization of the geometry of the building as a factor that would determine the buildings that would include in our study, and as opposed to size. What I can say is that geometry and size, in a way, they are interchangeable, because at the end of the day, you're talking about the height of the building and the shape of the building. That's what we refer to under geometry or size of building. We are talking about the height of the building and also the breadth of the building. Like she said, under height, we look at the vulnerability of building based on their height, because the higher the building, the higher the oscillation, the higher the frequency, and the more effects the earthquake will have on a building. And also the shape, if you have a deformed shapes, the most the most earthquake resistant shape is the rectangular shape. And so if you have any other shape that is different from that, we are saying that it will be more vulnerable because its stiffness is not as good as that of a rectangular building. So all those are weighted in a way, and then we use them to determine the buildings that will include in here. Matrix, the matrix was wrongly referenced in the report. Now you need to look at this, guys.
From what you put it, yeah, I'm going to.
Please try to ensure that you correct that, and we need to elaborate it further. Yeah, maybe you can. Fortunately, it's only members on the online who are going to benefit. Unfortunately, our battery is some. So there we have. You can take advantage of this. Maybe you can turn it a little bit for the benefit of the members. Project it from there. Okay. Now, what you see here is a sampling tool for the local government. In other words, we've talked about so many factors. We talked about the seismic factor, which helped us reduce the sample size from the bigger country to a region. And having gotten those districts within that region, we now had to use other sub-factors. You can see there we looked at the occurrence factor, number of the occurrences of earthquakes. Now M there stands for the magnitude of earthquakes. Then P there stands for the population. Then PD stands for population density, and EC stands for economic growth, projected economic growth, and H there stands for human-induced seismic activity, and HO there stands for the soil condition. Now we had now to use all these factors and weigh them and put them in a model to ensure that now we select the most suitable local government. So under each of these, for example, so this is just an extract. These are not called the districts, just an extract. So for example, when it comes to the occurrences, here we're looking at the number of occurrences of earthquakes in a particular local government. And we are saying that for us to be able to weigh these, we needed now to get the proportional number of occurrences in a local government based on the total number of occurrences within all the local governments that you're trying to sample. And so the next table there, you see 14 is the absolute number. Now 0.27 is the proportionality of the occurrence of earthquakes in this local government as compared with all the local governments. So now we have to get the average proportionality. And so in our weighting with the guidance of the statistician, all local governments that scored above average were accorded a factor of one, and those that scored below a factor of 0. And then under magnitude, the same thing. We got the total magnitude, got the average, those that were above average 1, those that below 0. Under population density, the same thing happened. Under population and population density, the same, we use the same approach. Then under EEC is the economic projected economic growth. So here we look at the projected economic growth, and we said that all areas that show signs of economic growth, we are going to assign them a value of 1. And those where the statistics are shown that there will be low economic growth, we assign them a value of 0.5. This was a bit judgmental, really, and then under human-induced seismicity, the same thing applies. All areas where there were such activities, we assigned them 1, and all areas where there were no such activities, we say that's 0 complete. So then under soil conditions, we use a factor of 2 and 1. So for all local governments that by and large have a poor soil classification there, generally, we assign them a value of 2 because we believe that they are more vulnerable than those that have fairly harder soil. And those we gave the value of 1. And as a result of that, we had a model. We had a model, yes. Now in that model, we're trying to get the total weightage. And here we're now trying to rank all the factors because not all factors are the same. So there was a ranking within each factor, and also now we have to rank the different factors. Because when you look at the occurrence can never weigh more than the population density, because now you're looking at the number of times earthquakes do occur. So you want to look at a place that has a higher occurrence than population density, and then also you can see occurrence is higher than the magnitude, because now here you're looking at the number of times vis-a-vis how often do they occur, because you do not know when a huge one will occur. So you're saying that, but for as long as a number of them occur, and literature shows that the more the frequency, the less the effect, but the less the vulnerability, because we do not know where the big one is going to occur. Then, yeah, definitely, and the soil condition was equivalent to magnitude, simply because definitely all buildings from soil, and it's very, very important that we look at the actual soil in a district as the critical factor. Coming up with this model, like you said, we all had to sit down and meticulously come up with our own understanding, and we now had to ensure that we come up with a model that would actually be a common denominator. So what we feel will suffice. Yeah, so out of that weightage, we realized that now here, this one shows you. Hoima ranked highest, and Kasese down there was second. Others were in between there. So I don't know whether it's more understandable now, but most of these things took us weeks and weeks of no lunch and supper. Okay, sourcing of quotations for field tests, I think I explained that. Updated project brief. Yeah, we actually, thank you so much for advising us wisely, Mr. Chairman. We thought of definitely including all that information in this phase, but some members felt that since we already submitted this stuff, so but now you've guided us well, we will include that information. Yes. And then in conclusion, there can be as many conclusions as the people themselves who will ever review the report. So we will try as much as possible and expound on it, so that at least it becomes all inclusive of the different areas that we talked about. Yeah, last but not least, he says that we need to update the metrics. There are figures that are mixed up in the different local governments. You picked it up, eh? Okay. Otherwise, thank you so much, Mr. Chairman. Thank you so much, members here and those that are joining us via online. We really do appreciate your comments, and we are going to go back in our think tank and give a deeper thought about them, because each of us has picked a different different perspectives, and when we get back down, we'll see our best to improve on this. Thank you so much.
Okay, thank you very much for the responses. And thank you, members, for all your contributions. Sorry, the meeting has taken a bit longer, but we want now to come to a conclusion. But first, before we conclude, I would like to hear from the team whether you think this is a report that should be approved. Shafiq, are you there? Shafiq, are you online? Gideon Abosa, are you still with us?
Yes, please.
What do you think? Should we recommend this report for approval with those comments?
With corrections, and as per our comments today.
Okay. Thank you. Consultant, how much time do you think you are able to rectify these and make a submission?
I think we request for a week, given the fact that we remotely now meet online. I think within a week.
So by the end of July.
By the end of July.
Okay, thank you very much. I think now the consultant is going to attend to the issues that have been raised and resubmit by the end of the month, so that we can now forward for the next activity. Of course, the immediate issue will be to approve this report, and then they will qualify for the next phase, and thereafter proceed with the planned activity, which is fiscal field work and capacity building, the counterpart staff. So I once again thank you all for attending and the consultants for the presentation. And now I want to declare this meeting closed. Thank you very much.
Thank you.
Thank you and bye.
Wait.
I think we can switch off.
You're free to leave.
Okay, thank you.
Okay. You are going with
You will
send it back.
go with it, so we'll return.
Send it back. When you come,